So hello everybody, my name is Lukas, I'm from Slovakia, I'm a software engineer, currently with roughly 10 years of experience in the software engineering area, and I work in Thermo Fisher Scientific, which is a pretty big company in the area of life sciences. So that's just to give sort of introduction about me so that you know who I am. And then I would like to welcome you on my talk, which I'm not sure if it's going to be exceptional, but it's going to be about the exceptions as the title suggests. So it's going to be about some best practices in the exception handling, about some anti-patterns, and maybe about the things that you don't know that exists in the new versions of C# and so on. So let's dive straight into it because there is a lot of slides so that we have enough time to make it. That's just the quote because I always like to start with a quote, my talks, and this one says that it's really important to have a good error handling in your application because people usually think a lot about the happy paths and so on. Also when they try to apply the clean code principles and so on, they think about happy paths. But from my experience from these 10 years, I have the feeling that exceptions are sort of third-class citizen, and people don't think about them that well. Also with the code reviews, people don't try to suggest different approaches to the person who wrote the code. So they just write some throw and they write some try-catch and that's it. But then the code gets messy in the area of exceptions and it's really hard to maintain it. It's not really discoverable, understandable, and so on. So it's really important to also take exceptions and sort of not happy path scenarios as the first-class citizens. Why it's important? It's definitely because of preventing application crashes. Because when something goes wrong, like there is no entity in the database that you are looking for, or something is null, or you are trying to access the array with the index that is out of bound, the app would crash if you would not have there some exception handling mechanism, and that would not be good for the user definitely. Then it's of course because of the code readability, maintainability, and reliability, because you want to tell other generations of the developers in your company like what are the possible error scenarios, whether they are intentional or non-intentional, so that they understand. And then it's about providing meaningful error messages to end users. It's like on the web APIs, for example, or generally at the web front ends. When something goes wrong, you want to tell the user what really went wrong, and you would like to, for example, hide some details because you would not like to tell the users about the implementation details. So good error handling also tries to get into this so that something that should be kept as a secret, some implementation details stays as a secret, and something that should be told to the user, for example, they are trying to save something that already exists, that should be achieved by this approach of good error handling. And then it's also about providing the meaningful error messages to developers because we are, not occasionally, but very often checking the logs, for example, and when something goes wrong, you would like to get the reasonable message in the logs so that you can investigate and you don't have to investigate a long time, you don't have to go through the code again, but you should get the good error message right at the beginning. So in the logs, you immediately see what went wrong. But first of all, let's sow some seeds of doubt, because actually exceptions exist in C#, I believe, since the beginning. And they also exist in Java and some other languages, but actually, is it a good construct, or is it something that should be in the language? Or because there are some languages that don't have exceptions and they are still used. First of all, with exceptions, there is a problem with transparency, for example, because in C# you don't have to, when your method throws an exception, you don't have to somehow mark it in the documentation or whatever. You can just throw the exception, and when somebody calls your method, compiler doesn't tell the user that there might be an exception. So that's a problem of transparency, sort of, that it's hard when you, for example, when you have some code that you cannot access, you just have the interface, for example, you cannot go into it, you cannot decompile it or whatever, it's really hard to know that there might be the exception thrown. Then, if you think about it, it's like a go-to statement, the exceptions, because when they are thrown, the compiler or the runtime tries to find the first catch block that is able to handle it. So you can jump a lot of levels in the call stack. So it's like the go-to statement, and go-to statements, I believe they still exist in C#, but the advice is that they should be completely avoided because, yeah, it basically is making the code readability and understandability really bad. So as I said, the enforcement of catching from compiler, there is nothing like that. So even if it's obvious that some method throws the exception, compiler doesn't make you to catch it. So you don't have to catch it. Then it's state consistency, because let's say if the exception is thrown somewhere in the middle of the method is not finished, let's say, there might be some finally block, but not always. So there might be the state corrupted, because if you are doing something, let's say some method that consists of 5 steps and the second one throws the exception, then it might be in some inconsistent state and you might do some rollbacks or whatever, but it's generally a problem. And also like what they mean in the real world, because if you think about it, a lot of things that you maybe model with exceptions in the real world, like they just happen. For example, you order something and you come to the shop and maybe it's not there if you come. So it just happens, and it's not like the exception, it's like a normal situation. So the problem is that we very often try to model something with exceptions that it's not really exceptional. It's really something that happens not very often, I would say, but still sort of often. What is the alternative to the exception? It's the union result type, for example. So you either have the actual result or some error. And do we have the alternative used somewhere? Yes, of course, it's, for example, in the APIs, if you think about it. So you either get the HTTP status code, for example, in the some .NET Core REST API, you return status code, for example, 200 with the JSON object, or you return status code 404 not found with some error message. So it's, you don't throw some exception out of the REST API. So actually, we have some places where the exceptions are not used, actually, some, let's say, exception-free boundaries. So that just to think about it, that exceptions are not, let's say, because very often I have the feeling that people think that what exists in a language, it's really nice to use, but it's always like you have to think about it, whether there is some alternative, and not everything that comes, it's something that you should prefer to use. It's like you should use it when it's appropriate, but not always, of course. So let's just quickly set some baseline. Of course, there is the try catch finally syntax. So you have a try block where you execute some code, then there is a catch. There might be multiple catch blocks. You should always start with the most specific exception, because the runtime goes from the top of your catch blocks. So if the base exception would be at the top and some concrete one would be at the lower, like on the lower line of code, then it would not be called by this catch block, but the one that is first. And then the finally block, which is almost always executed. There are some types of exceptions, as we will see, when even the finally block is not executed, like, for example, the out-of-memory exception in some cases, or stack overflow exception. So then the finally is not executed at all. You might have even just the try finally syntax without the catch block. Then some exception properties. There is the inner exception, where, for example, when you are catching something, some exception, you might throw some other one and put the one that was thrown before. You can put it as the inner exception of the one that you are going to call. Then it's a call stack. It's basically since the moment as the exception was thrown until the catch block that is handling it. So you might have there 2 methods in this call stack, or you might have there even more, depending on which level you catch it. And then the source property is the name of the application or the object that causes the error. And if it's not set explicitly, runtime set it to the name of the assembly in which the exception originated. And then, of course, probably the most famous one is a message. Then this principle, it's called least astonishment principle. It's basically about, let's say, discoverability, and also about transparency. So the system should behave in a way that most users will expect it to behave, and therefore not astonish or surprise users. So it means that if your method throws exception, it should be, for example, obvious from the method signature. It's at the bottom, method signature honesty. So it should be somehow clear that the method throws an exception. So for example, it might be named like try get entity or something like that, because then it might be obvious that if it doesn't exist, it maybe throws exception or returns some false as a boolean or something. And if it's necessary, if a necessary feature has a high astonishment factor, it might be necessary to redesign it. So if there is something in your code that is, let's say, not obvious to other developers in your team, and they tell you at the code review, you should think about it and maybe redesign. And when applied to exceptions, as I already said, it's about this method signature honesty, and also about meaningful exception messages, consistent exception types. So if there is, for example, some invalid argument somewhere, you throw argument out of range exception, for example, or invalid argument exception or something. You just don't throw arbitrary exception that comes. Then maybe something that is really interesting and you didn't know about it is the performance, because performance, they have some, let's say, overhead, performance overhead, and doing something with the exceptions, it's usually slower than doing it without the exception. So here just some simple example. There are two endpoints which are almost similar. They are used to do the division of numbers. The first one, also the second one, they accept the dividend and the division, and they just divide and return. They are in .NET Core API. And then there is the middleware that is used in the, I believe, in the first one. So because in the first one, I just do the division, and if the divisor is 0, then there is the exception cached by the middleware. And the behavior in both endpoints is the same, obviously, because also here you get the bad request and you get the message at the response. And also in the second case where I directly check, if the divisor is 0, I return bad request, and with the message cannot divide by 0. So the behavior from the user point of view is the same. So if you would call it with some HTTP client, you would get the same behavior. If you would call it with 0, I mean, you would get the same behavior for both. But if you look at the measurements, so for the first endpoint, the response, if you call it from some console application or something, it's almost 300 milliseconds. And if you call the second endpoint, where I check that the divisor is 0, it's just 1 millisecond. So it's, let's say, 300 times faster. So this should be really important, and you should take it into account that exceptions are making your applications slower. Maybe it's not a problem if you are doing some, let's say, standalone application that user installs at their machine and they are the only users basically there. It doesn't even matter whether it's 1 millisecond or 200 milliseconds sometimes maybe. But if you are doing some web API where you have hundreds or thousands of users, there even this difference might be crucial. So if you can design your endpoints or your applications generally without the exceptions, it might be much better from the performance point of view. And what are the reasons of the poor performance? It's basically there is some reflection in the background. So there is the stack and unwinding, because the runtime is trying to look for a catch block that is able to handle it. It might be a lot of levels above, and you basically want to capture the environment information, so all this call stack and all these properties that I listed there, so the stack trace and the source, the application, and so on. So this should be taken into account. Then the exception classification. It's Eric Lippert. It's one of the guys that writes some articles about the clean codes and so on, and he did very nice classification of exceptions. He has actually 4 categories. The first one is fatal. It's like out-of-memory exception or thread-aborted exception. And when it comes to these exceptions, it doesn't make sense to catch them because there is not much you can do about it. I mean, if you have thread-aborted exception, it's there is not much you can do. And even in finally, he considers to use the environment fail fast. So then even the finally block actually is not fully executed, only until this environment fail fast. And then he mentioned something like boneheaded exception, and it's basically a programmer exception. And it might indicate that there is a mess in your code leading to some bug. And into these boneheaded exceptions, he puts the exceptions like, or the situations like wrong typecasting. So for example, somewhere you expect the integer, you get the object and you think it's integer, but actually it's string. So you would get the typecast exception. So, and that's probably your fault because it's somewhere you want, if at some place you are doing a typecasting and it's not the type that you expect, it's probably like it's your error. It's not some logical error or something like that. Also the null reference exception or argument null exception, you should not catch them, but you should try to prevent them actually. So with the better code quality, code reviews, there is also he puts there also the exceptions like index out of bound exception, because if you have the array of 100 elements and you are trying to read the 101st one, it's probably your fault. It's not like some client problem or something like that. Then the vexing exceptions. These are the logical exceptions, let's say, or result of poor design decisions. And here, into this category, he puts exceptions that are thrown in cases which might easily happen, so that are not really exceptional. So for example, parsing of the input. Let's say you are getting some numbers from the user in the console or somewhere in the web form, and you expect it to be a number, but for example, the user enters the string, and you call the integer parse method, and this method, if there is not just the numbers in the string, it throws the exception. But it's basically like a poor design decision because you could check whether it's possible to parse it, because there is the alternative to the integer parse method. It's called try parse. So you should first check whether it's possible to parse it, and if not, you do something. But you should not do it that way, that you parse, and if you got the exception and you try to catch it. So these vexing exceptions are generally, you should try to avoid them by, let's say, checking for the preconditions and so on. So if you want to parse something, you first check. Or if you are adding something to the dictionary, you first check whether it's already in the dictionary or not. Or if you have some connection to the database or somewhere and it's already closed, you first check whether it's closed or not, and just then you call the close method. And then the exogenous exceptions, they are basically like vexing, but they are not the result of the poor design decision. They are more something that your application cannot really control. For example, if you are trying to read a file, it's out of control of your application, let's say. You might, for example, ask if it exists and then read it, but there might be the race condition. If you check whether the file exists and then you read it, it's still a few milliseconds, maybe 1 or 2 milliseconds. It's very short time between two lines of code, but still it might happen that somebody else out of your control in the file system, for example, deletes the file. So you still have to catch those exceptions, because it's possible. You are never able to, let's say, be 100% sure that there will not be the exception. If you get the input from the user, for example, it's string. It's like immutable. It will always be something that it will never change. I mean, if you check whether it's possible to parse it to the integer, you can be sure that at the second line you can parse it. But here with the files, for example, you cannot be sure. It's also like with the timeouts, for example. There might always be a timeout if you are calling the database. You cannot really check some preconditions. You cannot sort of try to determine what's the traffic on the network, whether it's fast. If you will call some database that exists in Azure, for example, it's not really possible to check whether there will be a timeout or not. So those are called exogenous exceptions. They must be catched and the application must react, because you have to do something if the file was not found or if there was a timeout when calling a database. You either retry or whatever. So then, of course, custom exceptions, you might create them. It's like domain events, for example. So you create your own exceptions. It improves readability of your application and so on. This is the exception hierarchy in .NET. So every exception inherits from object, and then there are, let's say, two kinds of the exception or two big subclasses. So first one is system exception, and the second is the application exception. Here are all the common exceptions that you know. For example, the null reference exception, argument exception, invalid operation exception, and so on. And always when you do your own exceptions, you should inherit from the application exception most of the time. I believe you will never inherit from system exception or something, because most probably there is already the exception that you need. Most of the time you will do some domain exceptions, like not enough money for withdrawal exception or something like that, and it will always be the application exception. So this is the hierarchy. And what are the pros? Actually, it's improved error specificity, much better debugging, because you can put the breakpoint, for example, to the constructor of this custom exception, and you can see when it's, let's say, when it's created or when it's thrown. And enhanced code structure, because you can, for example, put the exceptions together to some close to the domain in which they occur. And then very important thing is find usages functionality. In Visual Studio, when you are debugging, for example, if you would use the generic exception, you would not be able to find where it's thrown actually. But if you have some exception like not enough resources exception, or for not enough resources for withdrawal exception, you can just click Shift F12 and you will see immediately where it's thrown, and you can easily navigate through the logic of the code and so on. And also when you stop throwing the exception, you will see that it's not thrown at some other place, and you can remove the try catch from the place where it's actually where it exists. And because if you would have if you would use generic exception or generic exception class, and you would stop throwing the exception because the error cannot occur anymore, you are not sure then whether you can also remove the try catch, because if you are catching the exception, the base class, you don't know whether there might be some other exception and so on. So this way you can, even when you are refactoring, as I said, in the exceptional case it's not possible anymore, you remove the throwing, you remove the try catch, and there doesn't stay some leftover in your code. Yeah. And you can of course enhance the information. You can put there your custom data, and then the context of the error, you can make it richer, let's say, or if the properties that I mentioned at the beginning, if they are not sufficient to you, you can put some more properties to the exception if you create a custom exception. Yeah, so it's like payment exception, for example, not enough balance exception, or instrument control lost exception. And now let's get to some common anti-patterns that are there, that I observed during my career, let's say. So the first one is, can you see the code even in the back? It's fine. Okay. So the first one is catching the base exception. So let's say you have some code, doesn't matter, for me I put there some example of creating the curse in the university repository, so it's some university management, and then you are catching the base class, so the top level exception, and here you have some logic to handle, let's say, and here's some logic in case of error. And this can lead to hiding some unexpected bugs or to swallowing some exceptions, because maybe here you will have some logic to handle. You will check what is the type of the exception, and if it's other type, you will do nothing. So this can make some problems harder to investigate, because it's always better if you let the exceptions that are not somehow your fault, if you let them pass, and if you catch them, probably you are hiding some bug, and it might get back to you in the future. And this is really common anti-pattern. I see this in the code, even like more in the legacy code bases that I work on. I see it there very often, and it's not good for the maintainability and so on. And as I said at the previous slide, about these find usages and so on. So when the concrete exception is deleted from the code, you do not discover that. So for example, let's say that here at this add curse method, somebody throws like entity framework core exception, like DB update exception or whatever, or maybe some custom exception. And if they stop throwing it because the exception is not possible anymore, you don't find it out, and you are still catching some exception here, and maybe it's not even necessary because this method add curse stopped throwing the exception, but you didn't find it out because if you would have here like DB update exception and somebody would delete that, you would get the warning of the compiler that that class doesn't exist in the code base anymore. But this way it's still there, and in the future, like in 1 year or whatever, you come or some other developer comes and they are not sure whether this catch block is necessary or not, and then it brings the mess into your code base, and years by years it starts to be really problematic. Then throwing the base exception, very similar to previous one, and first of all, it enforces the caller to catch the base exception, which is the anti-pattern. It's not really good. And usually the caller must do some if or when. When is the new feature in, not really a new one, like it's already there for a few years, but pretty new, let's say. And they have basically to check. So for example, at the first picture, I throw the exception, and maybe they have to check like what is the exception message, or they have to use some heuristics to find out whether it's what they want to catch. Like because here, if you throw divide by 0 exception, they can catch just this exception and react on it. So that's common anti-pattern. And then exceptions, using exceptions as a control flow. So whatever might go wrong in your system and in your code base, and people first what comes to their mind is that I will solve it with the exception. So for example, when some order storage, when it's not available, they throw some order storage not available exception. Or when they do the validation, they ask whether the name is valid or the email is valid, and if not, they throw the validation exception. And one level above, they are catching the validation exception, and that leads to the bad performance and so on. So generally, you should always think whether there is not some other solution how to solve things. So for example, here you can just ask if the order storage is available, and you put it, if it's not available, you put it to the temporary order storage. If it's available, you put it to the order storage. Same for the validation, for example. If you get some request from the front end, you can validate, and if it's not valid, you throw some bad request, for example. You don't have to solve it with exceptions. You can just check, and if the preconditions are not satisfied, you return bad result or whatever. Then swallowing exceptions. This is also something I have seen very often. So for example, this is from my code base. I just changed it a little bit because I don't want to sort of put here the code from my company. So let's say I have a database and it's identified by the instrument URI. And basically in the constructor, when it's created the database, immediately the connection to the database is initialized, and basically in the code tries to connect to the database and so on. And in one place in the code, on the UI, we want to list all the databases in the dropdown. And even if they are not available, right? So what is there in the code, we are catching the exception, because if immediately in the constructor, as I said, we try to connect, and if it's not available, because it might be at some remote PC and there might be some network problem or whatever, so if it's not available, we throw some exception. And here, because we just want to put it to the drop-down, we don't care whether it's available or not, so we are sort of swallowing it. But this might indicate a poor design or dirty code, because obviously if we just want the name of the database, we should solve it some different way. It's obviously a problem if you are connecting to the database, actually, if you don't need it, if you just need the name of it. And so if you are swallowing the exceptions, if you are having empty catch blocks, It happens very often, and probably it's a code smell, and you should think about refactoring that one. The next one is putting all the code in a try block. So, and then having a lot of catch blocks, right? But the problem of this is that you don't actually know which line of code in a try block can cause which exception, right? So we have a lot of logic there at the beginning. In this example, it's just two things, let's say, but it might be much bigger in the real code. But here, let's say, first of all, we are validating, and then if it passes, the curse validator would validate, it throws the exception if it's not valid, the curse, and then we are adding the curse to the repository. And then we are catching exceptions. But the problem is again that it's hard to understand this code, it's hard to reason about it because you don't really know whether, here it's obvious because, but if the code would be a little bit bigger, let's say there would be 4 or 5 different things in a try block, then it would be really a mess. So you would not know what's going on and whether you can remove some catch block or whether it's still valid. Then also the hierarchy, it's hard to, let's say, keep track of the hierarchy of exceptions because if you have 5 catch blocks, it might happen that, let's say, the first one, it's the base exception of the second one, and then the second one, let's say, it's never used actually because it's always handled by the first one, and then it starts to be a mess. Then the leaky abstraction. The problem of this is that some low-level exception is catched at some higher level. This might not be a problem actually, that low-level exception is catched at the higher level, but in this particular scenario, the problem is that just because of this catching, I had to introduce the dependency on Entity Framework Core to this controller in ASP.NET Core. And if I would decide to change, for example, Entity Framework Core for nhibernate or whatever else, I would have to come also to the controllers and change the type of the exception here. So the leaky abstraction, it means that something that should stay sort of as a secret to some high level, it's actually revealed. So now the high level knows about the low level implementation details. So the controller knows about how you are implementing your database access. Let's say the controller knows that at some low level you are using an Entity Framework Core. If you would change it, again, the controllers would have to know about it. So a little bit better pattern, or how it's solved usually, it's that at some low level you catch it and you map it to some, let's say, domain exception. For example, you create the exception like entity not found exception, and you wrap the DB update exception into this one. So then, even if you decide to change the ORM, for example, you don't have to update the code in the high levels, you just update it in the low levels. And this controller, it will still catch the entity not found exception, for example, or concurrency exception or whatever. Then logging and rethrowing, another anti-pattern. So let's say at some low level, you are catching the exception and you are just logging it and then throwing. And then there is most probably it leads to the logs pollution, because most probably even in your controllers you are doing some logging. So this exception is logged again, and then you are checking the logs, and there was just one failure, but let's say in your logs there are 2 or 3 or 4 errors logged. And it also leads to the code duplication, because you might have some logging logic at some low level and also some more layers up. And now, so that we don't talk just about the negative things, now let's get to the best practices. So, as I said, it's precondition checks. So validate the input parameters before performing the operation, because sometimes you might know that there will be some error, let's say. As I said, for example, with these integers, when you are parsing, you know that it's not the integer, it's a string. So do that, but On the other side, try to avoid the too defensive programming, because it doesn't make sense to, let's say, check for something that is not possible to be 100% sure, but let's say you are 99% sure that it's never null, some argument, for example, so you don't check it for null. Or you are, let's say, 99% sure that you are parsing something that will always be the integer. For example, you store some value of the enum in the database with some ORM, and then you are getting it back from database. In this case, you might be 99% sure that you are storing it and it's in the integer, so when it comes back, most probably if somebody didn't go directly to the SQL, for example, via Management Studio, and didn't change it to some string, you might be 99% sure that it's the integer, so there it doesn't make sense to check, but it's a balance between the validation and defensive programming. What might help in this situation is so-called aspect-oriented programming. It's basically it's the approach where you try to extract or separate cross-cutting concerns from the actual business code, because let's say checking for the parameters is like a cross-cutting concern. Like it goes through all your application. In every method you would like to check the parameters. And this aspect-oriented programming is exactly about that. There exist various libraries that might help you. One of them is, for example, PostSharp. Also in Ninject, when you are resolving the dependency, you always map the interface to some implementation, and you can also configure it that way that before actual call there will be some class called, so it will be like sort of a middleware, and in this middleware you will know what are the method parameters and so on, and you can check it there, for example. So this way you nicely split the, for example, validation or the parameter check from the business code. So that's the first thing, or the first best practice. Then use of try methods. As I said, try add, try parse, try get value, for example, in the dictionaries, try it also in the dictionaries. So always try, for example. Also, as I said, the connection to the database when you are closing it, let's check if it was not already closed. Then the best practice is about the point at which you throw and at which you catch. So this is about whether to catch at some lower level, at some higher level, or both. As I said, sometimes it might be even both, because you want to abstract the exception, so you catch it very soon at some low level, and then you rethrow it, let's say, and you catch it also on higher level. And there is so-called throw early and catch late principle. So immediately in your code, when you know that there is something wrong, for example, you are already, when some method like withdraw money is called, you are immediately able to say whether there is enough money at the account or not. So you should, let's say, immediately check it and throw the exception. So throw as early as possible, because if you would start calling some other methods, then you might get into some inconsistent state. And there is also this catch late principle. So throw as early as possible and catch as late as possible. So let's say you should catch at the higher levels, because at higher levels you probably have much more details to log, because for example, if you have some library that is getting data from the database, it might be this get entity by ID, it might be called by a lot of controllers, a lot of endpoints, for example. So there you maybe don't have enough information to log, because you don't know what was the request or where it came from. For example, you have more front ends like mobile application or web application. At the low level, you don't know like where it came from, why it's problematic and so on. Why is there the ID that doesn't exist in the database and so on. So at the top levels, you probably have much more details. So that's what this principle suggests. And also at some higher levels, you probably have some better mechanisms, or you can put there all the logic basically. And then it's using of the union types or error codes. This is the example used actually. It's one library. It's called C# functional extensions, and it brings. There are very similar NuGets as well, but I decided to use this one. It's C# functional extension, as I said, and it brings a few classes or structures to the code. One is the maybe, another one is the result. And the first method would be the, let's say, the classic approach. So you want to get by ID, and you check, you try to find it, and you either return it, and if it's null, because find returns null if it doesn't exist in the database, it's find is entity framework core method. So you throw the entity not found exception. But you might, for example, use some other approach without the exceptions. So you can put the maybe to the signature and to the signature of the method, and it adheres with the principle that I mentioned at the beginning, this least astonishment principle, because with this signature, the user or the client of your method or the caller of your method immediately knows that it's possible that the curse doesn't exist, so it's maybe not returned. And the first line is the same, you try to get it, and if it's null, you just return the none, right? And it forces the caller of your code to check, because they don't get the curse back, they get the maybe back, and they can access it with the dot value, and they can ask whether there is a value or it's empty. Or the other possibility is the result class. It's a generic one. The first generic parameter is the happy path return type, I would say, and the next one is the set path argument or the set path return type. If you don't specify it, it's the string. So some error for some string, some message telling the user what went wrong. But you can specify it. For example, it might be curse, and the set path return type could be exception or some enum value or HTTP status code or whatever. And if the curse is null, you return the failure, right? Result.failure, curse with ID was not found. So that's one of the best practices or possible solutions. And this way also, as I said, with the performance, this way you don't have exceptions included if you do it with the second or third approach. So there will be even the performance improvement. Then the things to consider when you are logging the exceptions, you should definitely consider what should be logged, because it's very often that you catch the exception and the first line in the catch block is log error, and then you put there the exception. But there might be the problem with the GDPR, for example, because in the exception there might be some user ID, or ID is not a problem, but let's say some user sensitive information, maybe some, how it's called, the number that you get at the birth, like the personal identification number or something like that. It might be there in the exception, and if you would log the whole exception, it's possible that it would be logged and so on. So when you are logging, you should think about this, that don't log the whole exception, for example, just log the message and make sure that there is not some sensitive information to not break these GDPR principles. Also, the log level should be considered, because from my experience, people usually log the exception as the error, like always. Always when there is the exception, they log it with the error level. But for example, in the distributed systems, you might have some other machine that is not available, right? For example, you have client-server application, and it's very common that the server is, let's say, not available or whatever, and it's not really exceptional case, because it's like normal that there are problems at the network and so on. So for example, instead of immediately logging the exception with the error level, you might use the retry pattern. Like you try more times, and if it's not available, even after, let's say, 5 attempts, then log it, because it might be still important for your developers to investigate the problems. Maybe if something went wrong with some business workflow, they want to know that the remote machine was not accessible, but consider whether still log it with the error level, or maybe warning would be more appropriate. Then some good pattern is the circuit breaker pattern, and it means that when you have some, let's say, remote machine, and you know that it's not available at the moment, you sort of break the circuit. So your classes that are trying to call it would first ask some manager class or something whether it's available or not, and if not, they will not even try to call it, because if, for example, if you have some database in Azure and your network is down, we will most probably will not be able to save the data to the database because you are not able to reach it. So first of all, you try to ask. You can check this pattern at the internet. There is the exact names of the classes and so on that you should use. And you would ask your manager whether the Azure connection can be established and whether the database is achievable. And if so, you try to do it. And if not, you just, let's say, try in 5 minutes or whatever. Because if you would try to do it in spite of the database being down, you would get the error that it's not possible to reach it, and the logs would be maybe polluted and so on. So consider this pattern when handling with, for example, in distributed systems. And there are some must-knowns, just out of interest. I have prepared even some demonstrations, but it's just 5 minutes, so I will just go through it in the code. I have the examples, but unfortunately there is not enough time. So there are some uncatchable exceptions where even neither the catch block nor the finally block are executed. It's, for example, Stack Overflow exception, or when you call the environment.failFast, then not even the catch block is executed nor the finally block. So keep this in mind that there are some really rare circumstances, but there are, and your catch and finally blocks will not be executed. Okay, this will. Okay, I will show it in the code. Hopefully. Yeah, here I wanted to show, I will not launch it because it will take longer. I will just explain that one. Right, it's really important to know with the exceptions that if you have this approach, basically the methods are same. It's here I have some task that is throwing the exception, but those two methods are same. The only difference is that here I get the task and I await it, and in the first case I return it. And important to know here when it comes to exceptions is that in the first scenario, even if the task throws the exception, like here, it throws the exception, the catch block would not be executed because actually here I don't use the async await pattern. I just get the task and I return it. But getting the task doesn't cause the exception itself. It's just the execution code of the task that causes the exception. So in this case, this block would not be executed because I was able to get the task. Right? This is similar. This is the same as. Right? I got the task and I return it. But here I await it, so I wait until it's finished and I unwrap the exception, and I would here at the catch block I would get this invalid operation exception. Then async plus await is different to if you call the result. It's also important to know. Again, almost the same code, just in the first place, at the line 17, I call .result, and here I await it. And in the second block, what I get, the exception that I get would be this one, the invalid operation exception. But in the first, I would get the aggregate exception. So it's important to know that because sometimes you don't have, for example, the method where you call your task method is not async await, so you are not able to call await there. So a lot of developers, they call the .result, like, because that's what you can do. It's like a blocking call. You can do it. Compiler is not against that, but the exception that you get is different. So we would not get at the line 21, the type of the exception that you would get would not be this, but it would be aggregate exception. Yeah, this one, I guess you are all familiar with that one. There is difference between throw and throwx. If you use just throw, the call stack is kept. But if you use this throw exception, even the compiler or the not compiler but the resharper, I'm not sure if it's resharper or directly Visual Studio, doesn't matter, but you get this message that rethrowing code exception changes tag information. And then the exception filters, actually pretty interesting feature that is available from C# 6. It's catch when, right? You can use the catch block, and after the catch block, you can specify under which conditions you would like to use that catch block. So, for example, if you are catching the HTTP exception, you can specify that you would just use that catch block in case of the status code is more than 400, right? You don't want to catch or more than 500, because you want to catch the server-side errors, not the client-side errors. So when when status code is greater than 500, it improves the readability. It avoids ifs inside catch blocks. It gives you more flexibility. And best practices are you should use clear and short filter conditions, and don't try to. Actually, sometimes people use it to replace something like this or to check for the exception message, but it's not very good. So if you are usually trying to check for the message, then it's not good. So don't use it to bypass some good design. And that's it, basically just the key takeaways at the end. So there is a possible performance impact when using exceptions. So you should consider that one. You should try avoid vexing exceptions. Instead of that, use try methods at the beginning or before calling some method that can cause vexing exception. Always catch exogenous exception like file not found, timeout exception or something like that. And very important one, don't use exceptions for normal scenarios. And that's it. Thank you.